Welcome to this brief update of the fluids capabilities of 2019 R1. So one of the first things you're going to notice when you open up 2019 R1 in Fluent is the rather nice new GUI and layout. So there's been a lot of work to both modernize the GUI and then to improve usability. So one of the main aspects of this is the full release now of the watertight geometry meshing workflow. The idea here is that you can bring in a watertight geometry and very, very easily start using Fluent meshing to generate very high quality meshes in a manner which allows you to record, modify and script and redeploy your workflows. Very easy to use and very high quality meshes. So this is the new workflow. We start off in SpaceClaim, or it could be Design Modeler, do any of the important cleaning we need. Then we can move through into the Fluent GUI, where we can import that geometry, generate a surface mesh, decide what regions we want to keep in mesh. It could be just the fluid, it could also be the solids, volume mesh. We'll see that there's some new technologies here. And then one more click on the GUI and we're into the setup and solve capabilities. So we can set the boundary conditions, we can solve the flow, and then we can do high-level post-processing. So all in one window. It's a very, very nice workflow indeed. So expect to see more in this area and expect to see this demonstrated when you come to the CONVERGE seminar in May. So if you've used this previously in 19.2, you'll find that there's a lot more capabilities, more sizing commands. You can now do rotational periodicity very quickly in the GUI. There's a new parallel option for the hex poly meshing. And you can directly launch this workflow from SpaceClaim. So just to recap on the parallel hex poly meshing, this is a new technology patented by ANSYS where you connect a hex core mesh to prisms at the wall via polyhedra. It runs in parallel and gives exceedingly high quality meshes. So this is something that our customers have started to use and are finding amazingly good both in terms of mesh quality and mesh efficiency. Beta at this release is what we're calling a fault-tolerant workflow. This is essentially for more complex models where it would be impossible to extract a fluid domain easily, where there are holes, gaps, overlapping CAD. And this is leveraging all the tools that are in Fluent meshing to be able to clean and wrap and make yourself a high-quality mesh using exactly the same template idea. It's a beta feature at the moment, but it will be available as a release feature by the time we get to CONVERGE. A very nice addition, expressions into Fluent. So these expressions look very similar to what you would have seen if you were a CFX user, and you can now use those across boundary conditions, across zone inputs, and in many more places. This is an ongoing task, and these will get more extensive and more complex as time progresses. Mesh adaption has been revamped, so if you use mesh adaption, you'll find it much easier to use, streamlined, and much, much simpler. There's been solver robustness improvements. I guess the key one is that now, if you generate a setup in Fluent, you will automatically find in steady state that it puts you into the pseudo-transient solver, just as CFX does. There are also multi-grid improvements, and we'll talk a little more about this in May. The transient solver has been improved, so there's some new options to speed up the non-iterative solver, especially for single-phase flows. There's also speed up, allowing you, when you're doing scale resolving models, to solve the RANS equations at a lower frequency than the scale resolving components, and this is actually saving a lot of runtime. There's a new midfield acoustic solver, so you can do your computational acoustics in the near field, and you can still propagate into the far field. But this allows you to deal with those intermediate areas where you're not solving the full equations, but you also need to account for things like reflections. Strong coupling now between Maxwell and Fluent, allowing you to solve these coupled problems and to have a mixture of steady and unsteady solutions. This is a very big item. The Gecko turbulence model is essentially a compression of the vast array of two equation models into a single formulation here. And in order to control different physics, there are now properly defined coefficients which affect only one part of the physics. So you can make this model SST, you can make it like K epsilon, and there's additional models been added to allow you, for example, to catch 3D separations in a square duct. So a very, very important unifying turbulence model. In CFX, there's been continued development in the turbo area. The connection to 1D codes has been enhanced and released. We'll have a look later. The tools for operating maps have been improved, and there's a variety of other improvements. So what the functional mockup interface allows you to do is to quickly and easily couple 1D models into CFX, and this is all done through user functions and the expression language. So it's very, very easy to do, and it means you can link codes in very easily. Initially intended to allow you to use 1D codes for blade passage cooling, but this can be applied to many, many other applications. The idea of an operating map is when you want to analyze, say, a fan, a pump, a compressor, you never want to just do a single point. You'd like to look at the performance map across a number of speed lines and across the full row of interesting mass flow rates, etc. So there's a very simple way now of setting this up into a table, launching multiple jobs, and also generating the various maps and that you'd like back in the GUI. And the continued improvement of turbo tools. Remember that for rotating machinery, we have turbo grid, which allows us to get really high quality meshes onto bladed passages. There have been some significant enhancements here around tip gap and dealing with some new geometries, etc. So development there continues, and look forward to showing you more at the CONVERGE conference. So this has been a really brief run through. There are a vast number of other improvements that we haven't covered, but I think you can see from this, there's a massive focus on usability, reduction of solver times, and continued development of important models and technologies. With that, I'll sign off and hope that all of you will make it along to our CONVERGE conferences in May. Thank you.